Hello everyone, thank you for tuning in to this online presentation. Today I'm going to be talking about my work on SBOMs as a solution in the software supply chain. I'm Trevor Stolnaker, and up here on the screen you can see all of my collaborators and co-authors, without whom this work would not have been possible. So let's just go ahead and dive in. So before going any further, I want us to just imagine a scenario. Alright, so we have an open source utility that is being heavily relied on by downstream dependencies. And this open source utility is infiltrated by a hacker or by some group of hackers. And they go and they inject some malicious code and they push it to the online repository and it gets accepted into that utility. So now the utility has some sort of a backdoor in it or some sort of a vulnerability. And compromised versions of this utility are used downstream. And then those utilities and projects are used further downstream, and so on and so forth. And we don't need to imagine this scenario, actually, because it happened quite recently with the compromise of the XZ library, specifically versions 5.6.0 and 5.6.1. And if you'll recall, in 2020, we also had the SolarWinds breach. And these two are not isolated incidences. This actually happens more often than you would think. In fact, in 2022, supply chain attacks impacted over 10 million people and 1,700 organizations. And in 2023, in the United States, the reported supply chain attacks were over twice what was reported in 2022. And it's not just the traditional software supply chain that's being impacted. It's also the emerging machine learning supply chain, as we can see by all of these articles on the screen. So what can be done? How can we manage all of the risks that are just inherent to the supply chain? Well, in an ideal world, we would be able to easily check what is included in a piece of software. This would give us accurate dependency and version information. We would also be able to evaluate a software product before procurement, so we would know what is in it before we decide to buy or to include it in our build. We could also cross-reference with vulnerability databases to see if we're using a version of a library that has a known vulnerability in it. And we should also be able to maintain license compliance. It's not as flashy as security, but it's just as important. Now, this is where software bills of material come in as a solution, or SBOMs for short. And you can think about an SBOM as just a nutrition fact block for a piece of software. They're machine readable, and they're a manifest list of components or a component inventory that lists all the dependencies that go into a software build, the provenance information for those dependencies, so where did they come from, the licensing information for the dependencies, as well as the licensing information for the overarching project. And it can also include vulnerability information, but more often than not, the vulnerabilities are going to be found through that cross-referencing that we just mentioned. So much prior work has already begun to look at SBOMs as a solution to these problems that we just discussed. And they offer a promising solution. But they found that the adoption is still rather low. They're not being widely used. So we wanted to explore how SBOMs are currently being used, or rather how they're not being used, and understand what challenges and barriers are preventing practitioners from fully actualizing these benefits. So that's where we come in. And the way that we approached this was we looked at 5 different stakeholder groups. SBOM community adopters. Those are people that are already using SBOMs, producing SBOMs, making tools for SBOMs, etc. Developers that were contributing to critical open source software projects. These are the ones that are really foundational that most of the open source ecosystem is built on top of. We looked at machine learning developers to see if there'd be specific needs there. We looked at cyber-physical system developers to see if they would have any specific needs. We also talked with a legal practitioner to get the more legal side of things. And in doing this, we had 5 distinct targeted surveys, and we conducted 8 follow-up interviews, and all of that was distilled down into the current usage, the challenges that these developers are facing, and some potential solutions that emerged to those challenges. Now in this presentation, I'm going to highlight and just give an overview of the challenges because I think that's going to be what gives you the most comprehensive overview of the landscape. So we'll just dive in with some of the fundamental challenges. These are the ones that you would probably be able to put your finger on if you knew just the basics of SBOM. So first, we need to determine what exactly should be required, what should be the required data fields for SBOM. And this might seem relatively simple at first. Well, you need the licensing information, you need the unique identifier, you need the dependencies, etc. And that's all pretty well and good. But as we want to add more and more use cases, specifically like niche use cases, there arises a tension between that use case coverage and the complication of the spec. I'm going to paraphrase a quote that came from one of our interviews here. People will say that the spec is too complicated, and they say, you're missing something for X, by the way. I want that in the spec. Oh, by the way, it's going to make this specification more complicated for everybody else. Then another fundamental challenge is that of adoption and motivation. So there's regulatory pressure that is coming from governments that's motivating vendors at the end of the supply chain to produce SBOM, because the federal government in the United States, for example, is requiring software vendors to provide that. But there is little motivation or incentive for open source developers at or near the beginning of the supply chain. Some of these projects, for example, the Linux kernel might not have dependencies of their own, so there's no super apparent benefit that they would derive right there. So we need to figure out how to motivate them. There's also engineering challenges involved here. So we identified a couple of tooling limitations in our discussions with practitioners, one of which was the current tooling doesn't work very well on very large projects. It runs slow, it misses dependencies, these sorts of things. And that's really unfortunate because it's these large projects that would benefit the most from good SBOM tooling. There was also a lack of support for projects that were written in multiple languages. There was a lack or absence of tools for generating ML, AI bomb, or data bomb, which is going to be increasingly important as more and more AI applications are rolled out to the market. We're going to want to have provenance information for those pieces of software. And there was just a relative lack of consumption tools when compared with production tools. So you would be able to make an SBOM, but then what do you do with it once you have it? There were also ecosystem differences. So tooling quality could really differ dramatically between different language communities. This can be really well seen if you look at languages that have package managers versus those that don't. So languages like Java, Python, JavaScript that have those package managers are typically going to have better tooling options than languages like C, Assembly, C++ that don't have those package managers. That's because the package managers can do a lot of the heavy lifting when it comes to determining the dependencies. Now, one of the key challenges is that of accuracy and completeness. And I think a good argument can be made that an inaccurate SBOM might actually be worse than no SBOM at all. Now, what do I mean by that? Well, let us say that you are using dependency X, and dependency X has some kind of critical vulnerability in it. But your SBOM does not list that you're using dependency X. So you see on the news that dependency X is vulnerable and the world's on fire, and you go and look at your SBOM and you rest easy, you say I'm not using it, I'm safe, and you don't do your due diligence, you don't go back to the source, and you don't see that actually you are using it. So the inaccurate SBOM gave you a false sense of security, which leaves you and your project vulnerable. Now, what might cause an SBOM to be inaccurate or incomplete? Well, could be poor tooling, could be poor tooling configuration, could be just a bad review process, so you make the SBOM and don't even look at it to make sure, yeah, that looks right. Or it could just be bad project management in general. Another reason could be some kind of a data privacy trade-off. So let's say you're working on a machine learning application, or you're in the cyber-physical space. Well, then you might have information that you actually can't share downstream with your consumers. So the SBOM is not going to be as complete as it otherwise could be. So there's a tension between these two as well. There's also an inability, now this is rare, but there can be an inability to locate upstream dependencies. So this would be, you've downloaded a piece of code, you're using it, but its original version is no longer available. The repo is missing, it's no longer on the package manager, something happened. And now we can solve this through verification, but the problem is verification itself is a problem. How can a consumer verify that an SBOM is correct and complete without just going and recreating the SBOM from scratch? And if you think about it, it's going to be harder for the consumer to create the SBOM because they don't have access to all of the same information that the producer did. They don't have access to the build system, for example. And just a few more challenges that would be good to keep in mind. How can we keep SBOMs up to date? So every time that the software is changed, every time that a new dependency is added, how can we dynamically update the SBOM so that all of the consumers have the most accurate one possible? And then one that I found really interesting was SBOM for legacy software and just older versions of software. I think we can summarize it in 3 key questions here. What do we need to do if the source is no longer available? So for some older piece of software, maybe we only have the binary. That's all that's left. How do we make an SBOM for that? And how do we know that it's correct? Next key question, do all older versions of the software need an SBOM? So do we just start with the newest version and SBOMs from here on out? Or do we need to go back and retroactively create SBOMs for older versions of the software? Because a lot of those older versions are probably still being used by software out there. There's still projects that are using Python 2, despite the fact that Python 3 has become the default standard. So does Python 2 need an SBOM? And the third question, well, where are we going to get the tooling for less popular or legacy languages? Where are we going to find people that are motivated and have the expertise to go and make good tooling solutions for languages like COBOL or Fortran, where a lot of this legacy software is written in, but there's not a ton of developers on the market that are familiar enough with these that they could make the tools. All right, now I want to summarize with the main contributions of our work. So we conducted a comprehensive study of the current SBOM landscape that targeted 5 different stakeholder groups. We identified 12 top-level challenges, some of which I just highlighted, and we proposed 4 actionable solutions, which I didn't get the chance to talk about in this presentation. But if you're interested, please do check out the report. So that's all I've got. This was SBOMs as a solution in the software supply chain. If you have any questions, feel free to reach out to me. My email is there. You can also go to my website. And if you want the fullest version of this, here is a QR code to the version that was accepted at the International Conference on Software Engineering. All right, thank you for your time.